Hi, and welcome back to the wonderful world of the scientific hypothesis. My name is Brad Alger, and in earlier videos, we've mastered the concept that the scientific hypothesis is an explanation, it makes predictions, and we test the hypothesis by means of testing its predictions. We know that not all kinds of science test hypotheses, but you might have assumed that when the hypothesis does come into play, that it's always open and obvious. This, however, is not the case. As we'll see, it is common for the scientific hypothesis of a project to remain unstated. It forms the unseen logical structure of the project, but it never appears in so many words. You can tell that there is an underlying hypothesis because it's implied by the work and by its description. I call such things implicit hypotheses. And in this video, I simply want to introduce the concept, which is hardly ever mentioned in discussions of scientific thinking, and I'll put off the fascinating topic of why scientists don't always say what they mean for another time. All right, the implicit scientific hypothesis. First, I'll explain what that means. I'll distinguish two different kinds of implicit hypothesis and tell you why it's important to make the distinctions. And finally, I'll begin to get to the issue about why we should prefer explicit hypotheses whenever possible. The two kinds of implicit hypotheses are experimental and deep. The experimental implicit hypothesis is associated with the experiments we're doing. It is ultimately tested in the work that's underway. The deep implicit hypothesis is part of the foundational assumptions that go into the work that we take for granted. We assume them to be true, but we're not testing them at the moment. First, let's look at deep implicit hypotheses. These are also considered background knowledge. That their hypotheses follows from the ultimate uncertainty of all scientific facts. A fact is where the investigation rests. This is basically a set of well-corroborated hypotheses. They form the underlying assumptions that the work we're doing is based on. We take them for granted. Now, a given research community has a set of deep implicit hypotheses. For example, the neuroscience community accepts the deep hypothesis that the neuron is the fundamental unit of information processing in the brain, although this hypothesis has never been fully tested. Neuroscientists also accept all of the deep hypotheses underlying the operation of their equipment, for instance, of optics that are central to the operation of microscopes. It's important to keep in mind, however, that all deep implicit hypotheses can at any time be made explicit and directly tested. Now we come to experimental implicit hypotheses, and we'll compare them with explicit hypotheses. In the explicit case, the hypothesis and reasoning are directly stated. Usually they're easy to find and appear in the abstract or the introduction of a project or report. The implicit hypothesis, however, can be harder to find. The hypothesis and the reasoning here can be inferred but are not directly stated, and you may have to go over the entire paper in depth to figure out what it is. In the case of the explicit hypothesis, you might read, "We tested the hypothesis that," or "the hypothesis predicts." When there's an implicit hypothesis, however, you might read something more like, "The data suggests that, therefore we tested," or "X, some phenomenon, is poorly understood, and so we investigated." This slide highlights the major differences. In the case of the explicit hypothesis, the scientist is admirably clear about what she's doing. She states her hypothesis, predictions, the tests, how the results relate to the tests, and how the conclusions follow. In the case of the implicit hypothesis, the science may be equally excellent, and all of the elements of hypothesis testing are somehow present in the paper, but the author places a lot of the burden on the reader to figure out what it is that she really means. And this imposes a cost that we'll get to in a second. Now you might be wondering just how widespread a problem or situation this is. To get an idea, I've analyzed 210 papers. They were neuroscience papers, so they're in my field, and I classified them in a variety of ways, most importantly, whether or not the paper had an explicit hypothesis or whether there was an implicit hypothesis that organized the work. The details of how I did the classifications is given in the references below. In only about 20% of the cases, 47 out of 210, could I find an explicit hypothesis present in the paper. In another 66 papers, or about 30%, there seemed to be an implicit hypothesis. And the most important thing is that of the total of 113 papers, the majority, 58%, had a hypothesis that was never stated explicitly. From my own experience, I know that papers based on implicit experimental hypotheses require extra time and effort to understand, and so I thought I'd do a back-of-the-envelope calculation to see what the cost might be more generally. And I assumed that in a society, a large society of 100,000 scientists, I assumed that each scientist read 2 papers a week, or about 100 papers a year, and that 50% of the papers were based on hypotheses which were left in an implicit form. I assumed that it took an extra 15 minutes to read and understand a paper based on an implicit hypothesis, and across this group of scientists, this would mean an additional 1.25 million hours of wasted time per year. Now, in terms of money, if we assume our scientists work 50 hours a week, that would be 2,500 hours per year per scientist. In the U.S., the average salary might be something like $100,000 per scientist per year, or $40 an hour. And that would mean the total number of dollars wasted per year in trying to figure out implicit hypothesis-based papers would be in excess of $50 million. Even though these are large numbers, they may actually be underestimates. If we have more scientists who read more papers and spend more than 15 minutes extra per paper, the numbers could be very considerably higher. This is just extra time and money spent trying to figure out what each other actually means. The implicit experimental hypothesis is the logical glue that holds the project together. It provides the underlying unstated structural plan of a project. It gives the rationale of the project, explains why it was done. It accounts for the choice of experiments and techniques. It generates the narrative flow of the description of the work that is finally published, and it places the conclusions of the work in context, often justifying them. But reports based on an implicit hypothesis almost always are harder to read and fully understand than those based on explicit hypotheses. You can often figure out the implicit hypothesis, but it takes extra time and effort, especially if you're a reader outside the specialty area of the research. Finally, just to summarize what we've said about explicit versus implicit experimental hypotheses, first of all, there's no real reason to believe that the validity of the scientific results reported in either format are different. However, when it comes to matters of communication such as readability, comprehensibility, and efficiency of communication, there can be no real doubt that reports and projects based on explicit scientific hypotheses are much better. The explicit hypothesis maximizes the clarity of the communication. However, reports based on implicit scientific hypotheses tend to be jargony, they assume great familiarity, indeed they often seem to be written for a small group of experts and are relatively inaccessible to larger audiences or the general public. And I would strongly encourage any scientist to use the explicit hypothesis when you're preparing your next scientific communication. Thanks for watching. Remember to give it a thumbs up if you like it and subscribe to hear more. See you next time.